Hello, Physics Nation. My name is Nate Larmond, and it's the lecture you've all been waiting for. Significant figures, that's right. So, it's all about uncertainty. See, numbers in math class are ideas, but numbers in science class are measurements, and all measurements have some uncertainty. You have to know how much to trust the stopwatch, trust the, multimeter. Is this really the voltage? Is this really the length? How much can you trust the ruler? How much can you trust the scale? So significant figures are just a different way to explain uncertainty and what's sort of the wiggle room of the truth within your measurement. Every measurement has a little wiggle room, and hopefully the true measurement lies within that range of uncertainty. So the worksheet is pretty simple. You just listen to an example and then you try your own. So I think I have 7 rules. 1 through 9 are always significant. So in 14,000, there are 2 significant figures. The range of uncertainty is 1,000. That is, this number could be as big as 15,000 or as small as 13,000. Pardon the scrolling. Let's see. Zeros that are in between significant figures are significant. So this 0 right here, 0.205, is in between. Therefore, it's a significant figure. There are 3 significant figures there. The range of uncertainty is thousandths, so tenths, hundreds, thousands. This is fluctuating in this position. So 0.206 or 0.204 is the range of uncertainty. Whoops, sorry. Zeros are on the right-hand side of the decimal and on the right-hand side of the number are significant. So this 0 right there, that is significant. So we have 2 significant figures right here. The range of uncertainty is 100th. This could be 0.11 or 0.09. This fluctuates in the hundredths position. What's the next exercise? Zeros that are on the right-hand side of the decimal but on the left-hand side of the numbers are not significant. Right-hand side of the decimal. Okay, so this 0 is to the right of the decimal, but it is to the left of the number, so it is not significant. There's only 1 significant figure right here, and that's 5. The range of uncertainty is 0.06 to 0.04. So a small range of uncertainty, but we're going to talk about percentage uncertainty. This is a really big percentage uncertainty. Like if you tried to use a stopwatch to measure a very small time, it wouldn't be a very precise number because the uncertainty is almost as big as the measurement itself. Like the uncertainty is 20% of the entire measurement. So that's a lot of uncertainty. Anyway, we're going to talk about that a little bit later on. Zeros that are on the left-hand side of the decimal and to the right-hand side of the number are not significant. Right, so left-hand side of the decimal, there's no decimal here, but it's obviously implied. These are to the left of the decimal, but to the right of the numbers. So there are only 2 significant figures. All of these zeros are place-holding zeros. They describe how big it is, but they don't describe the range of uncertainty. This has a really big range of uncertainty. This is Jeff Bezos's net worth. He is worth $130 billion. So that's plus or minus 10 billion. He could be worth $140 billion or $120 billion. It's a large range of uncertainty. When adding or subtracting. Okay, so hang on. If you take Jeff Bezos's net worth and subtract $10,000, well, it's based on the least precise place value. This is uncertain in the 10 billions place value, and we are subtracting something that is uncertain in the 10,000s place value. So this is obviously much less precise. Jeff Bezos looks at the stock market and his net worth bounces around by, hundreds of millions of dollars. So $10,000 actually has no effect on his net worth. He gives you $10,000 and his net worth hasn't changed at all. It's kind of weird. And sorry, last example, we're going to find the volume of your tabletop. So it's just a box, it's just a rectangular prism, and if you do the thickness multiplied by the width multiplied by the length, well, it's a big long number that your calculator tells you, but it's a simple exercise. You just count the number of significant figures. So 3 is coming in, and then 3 is coming in, but then 2.5 is 2. So you have to round the answer to 2 significant figures. Addition and subtraction is all about place value. You round to the least precise place value, in this case 10 billion for Jeff Bezos. And multiplication and division is all about number of significant figures. You round to the least number entering the calculation. Thanks for watching. See you in the next video.